This is 2000 AIME II Problem 13. So we're given this sextic polynomial and it has two real roots, one of which can be written in this form here, where m and r are integers, m and r are relatively prime, and r is greater than 0, and we're asked to find m plus n plus r. So clearly the way to go for this rather trivial number AIME 13 is to factor this somehow, and there are a bunch of different ways you can factor this, but the one that's going to prove the most useful for us is if we group the 2000 x to the 6th and the -2 constant term together, and you're going to see why that works out so nicely in a second. So let's go ahead and factor like that. So we're going to group those two terms together, and then we're going to group the other three together. So we have 2, let's factor out the 2, times 1000 x to the 6th minus 1. And then for the other three terms, the only factor we can take out of there is an x, so we have 100x to the 4th plus 10x squared plus 1. Okay, so now notice that this expression right here is very nice. It's actually a difference of cubes. Well, we can factor difference of cubes in a special way, so let's deal with that. So the cubes that this is a difference of would be 10x squared and 1, because 1 is same as 1 cubed, and we can actually factor that in a special way. So I'll note as an aside that a cubed minus b cubed can be factored as a minus b times a squared plus ab plus b squared. So we'll just apply that here. So we have 10x squared plus 1, or whoops, that should be minus 1, times 100x to the 4th plus 10x squared plus 1. But now this polynomial right here is actually the same factor that we have up here. So now we can go ahead and group those together. So what we actually have here is 2 times 10x squared plus 1 times 100x to the 4th plus 10x squared plus 1. Or whoops, this should be minus 1. My bad. Minus 1. And then the other factor we have here is plus x times 100x to the 4th plus 10x squared plus 1. So now we can group the polynomial I just mentioned together. We can group those factors, so we get 100x to the 4th plus 10x squared plus 1 grouped together, and then times 2 times 10x squared minus 1, so that's 20x squared minus 2. Whoops. And then over here plus x equals 0. So now we have this quartic polynomial over here, and we have a quadratic right here. Recall that this sextic polynomial has two real roots. So basically we know that if this quadratic right here has two real roots, then that's the only one we need to check. Because then, based on the problem statement, this quartic right here must have all imaginary, non-real roots, or complex non-real roots. So let's just check what the solutions are of this. So we have 20x squared plus x minus 2. Applying the quadratic formula, we get -1 plus or minus the square root of b squared minus 4 times 20 times -2 all over 40. That gives us two solutions, so -1 plus or minus the square root of 161 over 40. Now go back up to the problem statement. We're looking for the solution with the plus sign before the square root, so the positive. M and r integers, r is greater than 0, yep. So now we just add these together. So 161 minus 1 over 40. Adding those together, we have 160 plus 40 equals 200. And that's it.